Welcome to video 3, where we are going to be going on a trip in the Wayback Machine and talking about the Bearcat model. So a long time ago, we created this beautiful thing, and I imagine most of you could go and create something just like this no problem today. So you guys have come a long way. This is great. But we're going to talk about a small piece of the Bearcat model in this context of identifying functional dependencies and candidate keys and normalization. So I'm going to take just a small piece of this, our employee, plant, and project relations or entities and the relationships between them, and also narrowing it down to just a smaller number of attributes just to save us a little bit of writing and a little bit of space on the screen. So we have these relations, employees, with 5 attributes: imp ID, fname, lname, address, and salary, and just one functional dependency that imp ID functionally determines first name, last name, address, and salary. So this relation is, at this point, because there are no partial dependencies, no non-key attributes being determined by just part of the primary key, no partial dependencies, it's in at least second normal form, and it appears that all of our non-key attributes are being functionally determined by the primary key, so we have no transitive dependencies, so we're in third normal form. That's a good place to be. For our project relation, we have just 3 attributes: p number, p name, and p location, and just one functional dependency of p number functionally determines p name and p location. So again, we have no non-key attributes functionally determining non-key attributes, and no non-key attributes that are being determined by just part of our primary key. So we are in third normal form here. But looking at our plant relation, where we have plant number, plant name, which is a composite primary key, budget, and building, which is a multi-value attribute, well, we're actually not even in first normal form because we have this multi-value attribute. And recall that we resolved this weeks and weeks and weeks ago by creating a weak entity for building that contained all of that data about the multiple buildings that might be part of a plant. So we're going to talk about how all of these attributes relate to one another, and how if we had designed this in a slightly different way, we might have had more problems in our database. So to save a little bit of writing and screen space, we're going to assign letters to represent each one of these attributes. So instead of writing imp ID every time, we're just going to have the letter A. And instead of fname, we're going to have the letter B, and so forth and so on down this list. And that means our functional dependencies that are in play are A determines B, C, D, and E, F, G together determines H, J determines K and L, and F, J, or F, G, I together functionally determines H. So A determines B, C, D, E is just imp ID determines first name, last name, address, and salary. So we could go through the entire process of synthesis or decomposition to identify candidate keys, but I think we could intuitively look at this and say, well, if A determines B, C, D, and E, and there's kind of a little bit of separation here, where F, G, and I determine H, and then a little bit of separation where J determines KL, I think we're going to have all of these determinants together to functionally determine everything in the relation. And just trust me on this, or work through it yourself, that our candidate key is going to be A, F, G, I, and J as one big composite candidate key, or imp ID, plant number, plant name, building, and project number all together. So at this point, this big relation is in just first normal form because basically every functional dependency is a partial dependency, because all of our non-key attributes are being functionally determined by just a small part of this primary key. So if we wanted to add a new project, like for example project 15, phones in Houston, we can't have null values for these attributes that make up our primary key. So we can't have a null value for imp ID, plant number, plant name, and building. So we would have to just kind of randomly assign some some employee to be associated with that project, and that really doesn't make sense. And we would experience the same problem if we tried to add a new employee. They would have to be associated with some project, whether or not they're really working on a project. Similarly, we have our deletion anomaly. If we wanted to delete this employee, Jim Wilson, well, we're also going to be deleting all of the information we have about this cars project that's running out of Atlanta. So what we want to do is take this big, messy relation with all of these partial dependencies and move our undesirable functional dependencies and the associated attributes out to new relations. Right? So since A determines B, C, D, E is a partial dependency, we're just going to move these attributes A, B, C, D, E into a new relation along with this functional dependency A determines B, C, D, E. Now in this case, A is a candidate key and is our primary key, functionally determining every attribute in the relation. And this is full functional dependency, right? Because none of these attributes are being determined by just part of our primary key. Okay, we could do a similar thing with plants, where we take these functional dependencies, FG determines H and FGI determines H, and move those out into their own relation. And same for projects, J determines KL. Now we have a good desirable functional dependency here. So there's a lot of overlap in this attribute, or in this relation, plants, and as I'm looking a little bit more closely at this, I think in order to determine every attribute in the relation, we do have to have FGI, but we can functionally determine H just using FG. So that is a non-key attribute being functionally determined by part of our primary key. So we have a partial dependency here that we need to further resolve. And so I think this is really the best place to land here. We move this functional dependency of FG determines H out into a new relation, and then here we have, this is our buildings relation that we use to resolve the multi-value attribute, where we have just the plant number, plant name, and building ID. And in fact, there are no non-trivial functional dependencies in this relation. It's just FGI functionally determines FGI, right? And then we can bring that back together with the plants relation, because FG is now a foreign key that refers to FG in the plants table. Okay, so now we have our four tables all in third normal form because we have no multi-value attributes, so that gets us in first normal form. We also have no partial dependencies, so that gets us into second normal form. And we have no transitive dependencies, so that gets us into third normal form. So now we are in good shape again. So to review, to be in first normal form, we have no multi-value attributes and all of our attributes are atomic. And this is just the rule that we have to meet to be in a relation or to be in a database at all. Second normal form means you are at least in first normal form and you have no partial dependencies. And third normal form is that you are in at least second normal form and you have no transitive dependencies. Okay, so homework 4 was posted on Monday, April 13th. This is very, very similar to the exercise we went through in modules 8.2 through 8.4 in the part 2 video. So I'm going to provide you with a couple of relations and sets of functional dependencies, and you will need to identify candidate keys using both the synthesis and decomposition approaches, and at each step you're going to identify the normal form that that relation is currently in, and you'll normalize until you get all of your relations into third normal form. So all that said, I know this has been a lot of information that's been coming at you, but these problems can be pretty complex, so I would strongly suggest you work through these by hand and get some practice in. Hopefully you caught the virtual in-class exercise that was announced in the previous video in this series, so go ahead and make sure you get that done. But other than that, I hope you guys are all safe and healthy and doing great things, so we'll see you next time.